Alright, so the next thing that we want to take a look at is like just a follow-up from the first video, and that's still looking at these graphing techniques and understanding transformations. And so what we want to do here is be able to look at these and identify the parent, and then be able to identify the transformations, and then I want you to use your graphing calculator to be able to understand what the graph would look like compared to the parent function. So this is where I'm going to go really into depth with how we use our graphing technology to visualize these graphs. So obviously the first one, just watch it through, copy it down, but then you can see we're going to go through, we'll have 2, 4, 5, 7, and 6, 8, and that's it. So, but on the next ones, after the first slide here, I would like for you to, I'll roll over, you go ahead and hit pause, do the problem, and then hit play and watch it and see how you did. Alright, and I'll explain that again just real briefly when we get there. So, alright, so taking a look at this guy right here, we say to ourselves, what is the parent function? Well, when you scan through here and you think about your parent functions, we see that the parent function is x squared. So the parent function is y equals x squared, which is known as a quadratic. And that goes back to that initial slide right here where I told you to kind of make sure you have these down and you have this visualization. So remember, essentially what's going on now is we're saying, all right, well, this graph obviously has a transformation. What is that transformation? What does this minus 1 do to this guy? So hopefully you're looking back at your notes and you're like, okay, that's the k value, right? So this is going to be a vertical shift down one time. Alright, so we pull out our graphing calculator, we go to y equals, clear out whatever's in there, and let's put the parent function in first. I want you to graph these so you can see what your graph did compared to the parent function. So we type in x squared, arrow down, type in x squared minus 1. Alright, remember every time you grab your calculator, just make sure your window is set up right. We hit zoom and choose number 6, the zoom standard, which gives you a 10 by 10 window. There's my parent, and there's the new function. And so you can clearly see that that graph has been shifted down one time. So when we come back here and we think about our graph, if we draw a sketch, you know, these sketches are just for us visually, so that would be the parent function, and we shift it down one time, that would be our new function. That would be our x squared minus 1, just shifted down one time. Alright, we roll on to the next one, and let me hit pause just for 1 second. Alright, I went and got a fancier calculator out so it would be a little more colorful. So in this case, same deal. We take a look at this and we say, okay, I see two transformations. I see a negative out in front and a minus 2 on the end. So according to our rules here, we know that that would be an a value out in front, and we know that if something's on the end, out on the back, that would be my k value because it's not under the radical. So when we decide on our parent function, that's y equals the square root of x. So then our transformation is that this would be the negative out in front would give you, I got to spell right, would give you a reflection over the x-axis. That would be the negative on the front. And then the 2 on the end would give you a vertical shift down 2 times, or a translation if you want to use the word translation instead of shift. So let's take a look at it in our graphing calculator. So we pull this up. Remember, the first thing you're going to do is you're going to type in the parent function. So our parent function, let me make this a little bit bigger. Doesn't look like I have that option. Alright, so the parent function in this case is the square root of x, so second square root of x. And then our next function is a negative square root of x minus 2. So we want to see the differentiation between those two. We hit graph. There's our parent function, and there's our transformation. So we take a look at that and say, okay, so our parent function, I'll do it in black right here, is basically looks like that. That's the standard function. That's what the square root of x will always look like. When we transform it, that means we're going to take that guy and we're going to take this point right here, or any point on this line, but the easiest one is kind of the one right there in the center. We're going to move him down 1, 2 times, and then we're going to reflect him over. You could also think about it this way. You could think that I'm going to reflect it, and then I'm going to take that and move it down 2 times. So you get your graph. Now, don't worry. If you're not able to draw the graph, don't freak out and be like, I don't get it. The assignment, and once you open up the homework, you'll see this. Sorry, I got a little button happy. Once you open up the homework, you'll see this. The assignment does not require you to draw this stuff by hand. Okay? The assignment asks you to be able to identify the characteristics, the transformations. So don't panic and be like, I'm not going to get this, I can't draw the graph. Okay, so go ahead and hit pause, do both of these, and then come back and answer, and then listen to the video, okay? So I'm just going to go ahead and go through it quickly. In this case here, we have the 2 on the front, and then we have the -1 underneath. Alright, I hit pause there, and I can get my brain back right. Alright, so I go through here, identify those. The parent function for this guy would be y equals the absolute value of x. The 2 in front would be a vertical stretch. Two times. So it would be making it stretch out twice as big. And we'll look at that in another video later on. And then the -1 on the end. So remember, that -1, it does the opposite. So you're inside, you do the opposite. So that would actually be -1 is to the left. You know, if you think about a number line, right? So normally -1 is right here. That's to the left. But we're not going to shift to the left. We're going to do the opposite. We're going to go this way to the left 1 time. So that would be a translation. I just call it a shift to the left 1 time. Alright, so at that point you can plug it in your calculator and take a look. Clear that. So that's 2. Absolute value is located underneath the math key. So you hit math, you go over to num, and you choose number 1. Okay, and I'm not writing that down because I figure you can hit rewind and watch it again. So then you got, oops, I did it wrong, but that's okay. So now I've got that typed in. I'll come down, I'll put the parent function in right here. So math, arrow over to num, choose number 1. So I got my parent function and my transformation function. I hit graph. There's the transformation and there's the parent. So the parent, when you look at this guy, and I'll use the colors they're using. So the parent in this case goes through 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Because when you make a table of values here and you think about the transformation, you plug in 1, you get out 1. You plug in 2, absolute value 2 is 2. You plug in 3, you get out 3. You plug in -1, you get out +1. You plug in -2, you get +2. You plug in -3, you get +3. But now if we do the transformation, we shift that guy over to the left and we scale it up by a factor of 2. So that means if you plug in 0, you're going to get out 2. If you plug in -1, you're going to get out 4. You know, so it makes everything grow twice as fast, which is why we see that V looks a little bit steeper there on that particular graph. All right, remember, if you want to check those ordered pairs, because there is a question later on in the homework where they ask you to graph that, you can always hit second and table, and you can see your ordered pairs. So you can see where I got that 1, 0, 2, 2. Oh, I was off. No, I'm not. There it is. 2, 2. And then you've got 3, 4. So over 3, up 4. And then we go into the negatives. And you can see I have -1, 4. And 0, 2. You know, so you can see that we can actually get the values of our functions from our table, which is located as second graph. Alright, so I'm already at 9 minutes. So I don't know what I'm going to do. Let's just do one more of these and then you can practice it in your homework, alright? So hit pause right now if you haven't already done number 4 and do number 4. Alright, so here's the conversation. On number 4, let's do color coding here. So we have our A value, we have our K value, and we have, that is not our K is on the end, and we have our H value right there in the middle. So we've got our three different colors. First thing we know is that this is a quadratic. This is an x squared. So this is y equals x squared. So when we look at what's on the front, we have two things. The negative on the front reflects us over the x-axis. Reflects x-axis. The 2 on the front gives us a vertical stretch 2 times. And just for the record, I know that I spelled stretch wrong on the last screen or over here. So in case you're like, wow, he spelled stretch wrong, he didn't even say anything about it. I knew that. I just didn't want to go back and take the time. All right. And then the H, the 1, the plus 1, that is going to be a shift to the left 1 time, because positive 1 is to the right. We do the opposite and go to the left. And last but not least, and I'm just going to write it right here, the 3 is going to be a vertical shift. I know that's really hard to see, 3 times up. So a vertical shift up 3 times. So just take a quick second and plug this in, clear that out, put my parent function in, x squared, clear that one out, negative 2, open parentheses, x plus 1, close parentheses, squared plus 3. Graph those and see what we see. Parent function. So if we take a look at that vertex, let me grab this guy and pull it over here on the screen and we can look at it. So when we take a look at that vertex on this guy, so we're looking at this guy right here on the parent function. If you think about what that guy's done, he's moved over 1 time. So to go from here to here, he's moved over 1 time to the left. That's our shift to the left 1 time. He moved up 3 times. Excuse me. Yeah, 1, 2, 3. Up 3 times. That was our vertical shift up 3. At some point, he also reflected, and I did it out of order. Really what you're supposed to do is you're supposed to do your shift to the left or right, then you do your reflection, and then you'll do your transformation up or down. But you can see that that makes perfect sense. That's what I get. Alright, so that's going to be the graph there. Like I said, we're not going to do a lot of identifications from the graphs. We're going to do more so from the equation. So hopefully that'll get you going on the homework on that piece.